Guys, let's get started. So today we are covering Bash scripting. So that's going to be the topic for today, this week. Right. So we're reporting here. We've covered many topics of Linux throughout the semester, various things, various functionalities, right? And today we are going to look at Bash. Okay, so I'm going to start the virtual machine just so that it gets going. We're going to be doing scripting basically, and then you can expect on Thursday that I'll give you some problems. That will probably be your last homework assignment. Okay, so that's going to be your homework assignment. If you've missed any homework assignments, I always provide a bonus homework, and that's going to be the week after the file system analysis one, which is not difficult. But yeah, so we'll talk about that when we get to it next week. But this week, basically, is kind of like the last topic of the semester, unless there's any like miscellaneous little things that I still want to cover. So Bash is it's nice, right? It's powerful to a certain point, right? So once you go past like, I would say 40, 50 lines of code in Bash, I would probably recommend switching to something like Python or Perl, with all the libraries and everything. But for something that's short, maybe even 100 lines of code, and certainly a lot of the scripts, in Linux, that the native ones for startup and everything like that are going to be in Bash. Okay, so it's important that we have an understanding of that one. So we'll cover that this week. It's a very big topic as well, so I may take it as far as I think it's fun, right? So we'll be doing that. So today I'll just do some scripting examples. Bash is not forgiving, okay? So you can spend hours just trying to figure out what the error is. But we'll do some examples. I have several, easily like 10 to 15 examples of different things we will do, and then we'll start looking at running some of the Linux commands in Bash. Yeah, and then just go from there. Okay. But it's the common theme of the semester has been what? Automation, right? So you don't want to do, as a system administrator, you really do not want to have to create 30 accounts manually, for instance, right? You want to automate everything. And so that's kind of what we have stressed. And so, as I said, in general, I mean, I prefer Python, for instance, but definitely, every now and then having Bash, you're going to encounter it. So important. Okay, any questions before I begin? I graded your exams. You can take a look at that. I've graded some of your homework. Once I finish the other exam I'm grading, I'll get all your homework graded, most likely. So yeah. All right. Any questions? And then please don't forget, presentations are 2 weeks from today, right? Tuesday, 2 weeks from today. Remember, you have two projects, Project A and Project B. Project A, the Hadoop one, we talked about that already quite a bit. And then Project B, configure something in Linux. So both of them are Linux configuration problems, basically. Just test your skills in Linux to install something. That's what sysadmins do some of the time, right? So you want to definitely deal with installing things in Linux. Any questions about that, the projects A and B? All right, great. All right, so let's go ahead and get started. So I'm going to just motivate. So we're going to start with very basic scripts in Bash. I need to tell you some things about Bash on Ubuntu. So we'll talk a little bit about that as well. All my scripts are on the GitHub, so you can get them from there if you'd like. But I'll just type them up and describe them on the terminal. Okay, so let's go ahead and get started. All right, so I have the scripts here. So I'm going to navigate to the desktop, first of all. Okay. to ATS 372. Okay, clear. And then I'm going to create a new directory here called, my bash, let's call it. And I do this because I don't like, in general, things that have names like file names, like important file names in Linux, for instance. All right, so I always change that a little bit. Okay. All right, so let's go ahead and do that. So there it is, my bash. So I'm going to cd into my bash. And we're going to talk a little bit about that. All right, so when you guys take 450, ITS 450, I don't know if you've taken it already, software assurance, part of that class will be dealing with low-level software, like C software. And you're going to be looking at some vulnerabilities with that type. And some of those vulnerabilities will revolve around bash, okay? So bash are command interpreters, are basically just programs, files, are executable. And there's actually several. There's many. There's CSH, there's dash, there's bash, so you get the idea. So some of those can have vulnerabilities. And that's actually one of the labs in 450 is basically using CSH, which is like bash, a type of a bash, but there's a vulnerability in it. And so you're going to exploit that vulnerability to achieve something. And the command actually relates to setuid. So it's another term that's really important in Linux. Okay, so anyway, there's several. And so what do we want to see? We want to do something like ls-l etc or bin sh. What do you guys see there? I ran this command ls-l bin sh. Tell me everything about it. This could be like, I may be giving you right now one of the questions on the final exam. So what is this? What are you looking at? In this output. What do you see there? What's that L at the very beginning of the row? This L here. What does that mean? Does that have a meaning or is it just there randomly? It means link, right? What does this arrow here mean? It's a link also, right? It's the file that it's linked to. So in fact, when you guys do something like sh like that, guess what? You're not actually calling a program itself. You're calling a symbolic link, which is pointing to something. And look at what it's pointing to. It's pointing to something called dash, which is like bash. It's just the same idea, but implemented differently. And there could be a thing. I could change that symbolic link. I'm pretty sure I could change it to CSH. I think CSH exists. Let me try that. It does exist, right? It's right there. That's another bash type interface. Okay, command interpreter. Does that make sense, guys? So there's several bash dash CSH. I believe actually on the seed VM, this CSH has a vulnerability that can be exploited. So if I wanted to, I could change bin sh to point to CSH. Most people would just type sh. It would work most of the time, but there would be a vulnerability there. And you could take advantage of that. Do you guys see that? So there's several of these. So I just wanted to point that out because there's vulnerabilities that are in Linux even. I mean, a big one came out recently, right? Have you guys read about that? Like in the last month, a really big one, right? So, yeah. So if you guys want to read about it, send me an email. I can send you the information. But they discovered a really big one that I think has been updated now, patched. All right. So let's go ahead though. So anyway, so basically these are programs, CSH, Dash, and Bash are programs, and they help you to run Bash scripts, for instance, right? So today we can use SH, but Dash and Bash don't actually handle code the same way, Bash scripting code. So I'm going to use the more like normal or common term Bash for these, okay, for these scripts. So that means that instead of running SH, because if I run SH, it'll call Dash actually, I'm just going to type Bash itself. Do you guys see that? So that's what I'm going to do. I could change the symbolic link, but the CVM comes in a specific way, and I don't want to break your CVMs. Okay, so, and that, that's basically it. Okay, so, we can invoke this with our scripts, basically. All right, so we are now, all right, so I'm in the My Bash folder. So we're going to start just running some scripts and just getting into how Bash works, okay? And they're going to get a little bit more complicated as we continue, basically. But it's going to be the whole bunch of things, the basic things that you do in programming for scripting, and then, running some commands. So basically, the nice feature about Bash is that anything that you type on the terminal, like ls-l, you can just put in the body of a Bash script without having to use something like subprocess, etc., like we have to do with Python. So that's kind of nice. I like that. But it is also not very forgiving in terms of syntax and spelling and errors, basically. Okay. All right, so let's go ahead and begin. So I'm going to create a script. I'm going to call it script 1. Actually, I'm going to call it, let's just call it simple if statement, because otherwise this is going to get confusing. All right, so simple if statement. You can use the extension .sh. Remember that actually in Linux that is not, it's meaningless basically, right? So we handle these things differently by something called a shebang at the top and making the file executable, right? So please remember, those are the things that we use. But SH can help you to know that these are Bash scripts. Okay. All right. So I'll use the same convention. But let's go ahead. So I'm going to do first one. All right. So yeah. So this is called a shebang. Okay. Basically, you do this and something like that, and then you can make the program executable with chmod, and you guys know how to do that, basically. All right, bin bash, as you know from the file system, bin is where you keep your programs, and then you have bash. Okay, another thing, actually, I'm gonna do echo $. Path. Right, this is actually your path in Linux. So basically, these are the folders. So whenever you run something on the command line, etc., these are the folders in the file system that your script is looking for. Do you see what I'm saying? So they're separated by colons. You can see, for instance, here is bin, the one that is looking for. All right, so this is a feature also in Windows. I'm sure you guys have worked with your path at some point, like adding a program to the path, etc. And so this is kind of how it works. So basically, we have a command interpreter that we are running Bash. We're looking for it in bin, and basically we go from there. Does that make sense? All right, great. So let's go ahead. So we did that. So now let's get back into the script. So we have it there, simple, nano simple. All right, so that's the shebang. If you guys want to add a comment, you can do something. So for instance, my comment here is going to be using Bash instead of dash or sh, right? I'm not using sh as I've explained because sh is a symbolic link to dash. Okay, so you can add a comment. Then we're going to do a simple example and kind of show you the frustrating things sometimes about bash. So let's create a variable base equal, and then I'm going to say something like that. So I'm going to do just some if statements just to kind of get started. Then I'm going to create another variable dm, oops, wx, just some letters. And then I'm going to create some if statements. So I'm going to say if, then you have to do double quotes, $, base, right? Notice that whenever I declare the variable, I declare it without the $, but once I reference it, I'm going to use the $, okay? So you can see this here, equal Z, I'm going to make this uppercase Z. So I'm just saying if and in bash, square brackets again, $, dm, which is the other variable being referenced by $, equals x, semicolon, okay, then. Okay, so this is the syntax for the if statement, okay? So I'll definitely go over the basic programming structures, arrays, for loops, and things like that today. Okay, just so that we have a sense. Yeah, go ahead. Yeah, definitely. Better. Mm-hmm. All right, makes sense, guys? And then if we want to print something out, we're going to do echo. No need for the indentation, although I would say be consistent. You know, I'll do like 1, 2, 3, 4, 5, 6. Just, you know, echo. And then we're going to echo, you know, the letter A if it meets some condition, right? Then I'm going to add the elif. So that's else if. And I'm going to say $, once again, base equal W. So this, I want it to match this one, right? I want it to match this condition, and then we can play with it. And double quote, $, dm equal wx, right? The two variables. So it should match this one. Semicolon, then be consistent here. So I'll make them align. Now I'm going to echo B. And then else. So if nothing is met, it's going to echo, you know, say PNW. All right. And then finally, let's close it. So FI. All right. So this is basically how you do, you know, the if logic in bash. Let's see if we get any errors here. Okay. Let's go ahead and run it. Control X, Y. So now, as I said, I'm using bash directly, right? So I don't want to use dash. So I need to do simple. And as you can see, giving me errors here. Okay, so I intentionally kind of did that. Line 8 command not found. All right, so let's take a look. We want to definitely get rid of these two statements here. So it's saying on line 8 and line 10, W. Let's take a look. So it didn't like, I think, which one? Which one? W equal uppercase Z. Uppercase Z. So it's this one, right? So the error is here. Okay. So usually, let's add a little bit of space here now. Do that and that like that. And then I'm going to do this here. Okay. Let's see if the error changes. Okay. Now it's saying W equal W. Doesn't like that one. So that is gotta be the second if statement, right? So this one here, that's base, and the other one is DM. So let's do the same thing. Space, space, space. And let's add space here. And space. Do you see that? So let's go ahead and try it. Okay, no error this time. So as that shows, Bash can be a little bit particular about syntax and spacing. So be careful with that. Yeah.
Can you show it again? I'm still getting errors on mine.
Yeah, sure. Yeah. So as you can see, it's really, I wanted to show that, it can be a little bit frustrating with spacing and formatting. So let's change this. So now I want it to print A. So basically, I should change this to uppercase Z, right? And this one to uppercase X. And then basically, if we should meet the condition at the top and print A. Bob, did you figure out? Yeah, space here, space here, space here, space here. Then space here, space here, space here, space here. And the same for the bottom ones. Okay, let's run it. You can see now it prints A. Let's go back. Let's add the W, lowercase w, and the WX. Okay, so it should print B. B. Okay. And then I'm going to go and then just add like another X, and then it's not going to match any of the conditions, so it should just print the last option. Yep, there you go. Does that make sense, guys? So that's a quick intro into, so I'll leave it up for a little bit. That's a quick intro into Bash. Okay, so we'll be doing some examples of this today. Like I said, it can be a bit unforgiving, but it is certainly the native scripting language for Linux, so you are going to encounter it. All right, so let's consider another script now. So we're going to do just a simple script of string manipulation, getting some inputs from the terminal. Okay, so let's go ahead and create another one. Let's call this one reading text. Okay, so I'm going to do Control X, clear, /L, say read in user. Okay, .sh. All right, so we're going to go ahead. This one's going to be a short script. Again, the shebang. Bin bash. Okay, then I'm going to say echo what is the temperature today? Okay, something like that. And then you can read in So you can say temp 1 maybe. All right, and then we're gonna echo out the same. So I'm gonna say, wow, it is really, no, wow, we have to write the temperature on. The temperature of, and then now we have to reference the variable. So I'm gonna say $ temp 1. You guys see that? So wow, a temperature of is really nice. Okay, and then double. Okay, so basically we're going to read in this in to the program. So Control X, Y. So now I'm going to do bash again. What is the temperature today? You guys know it's like 65, I think. 65. And there you go. Wow, a temperature of 65 is really nice. So basically a reference with a $ is common. Okay. So bash can be easy to use once you're like figure it out, but if it can be frustrating when you're building a new script. Keep in mind also there's a strange behavior, and I think I've mentioned this. If you run these scripts with sh, some of them won't work because it's using dash, right? So it's not like there's variations there. So remember that if you decide to do your homework and start using sh and nothing works, you know, remember that detail. Okay. All right. So let's think of another example. Let's do another if statement. Another if. I'm going to do clear. Almost that. No, nano. Let's call it other if dot sh. So again, shebang. So that's going to be bin. Oops. Exclamation. Bin bash. Salary. It's going to be equal to 1,000. Expenses equal to 800. Okay. So you can comment your own code. You can say check if salary and expenses are equal. Okay. So then you can say if $ salary equal. Notice I'm using a different symbol here. If salary equal expenses, right? This is also numeric. Semicolon, right? And then we can do also then here, like that. And, you know, 1, 2, 3, 4, 5, 6, just because. Echo. So now you can issue a message. So you can say salary and expenses are equal. Okay. Then we're going to add another comment here. Check if salary and expenses are not equal. Okay. So again, elif at the square brackets, space, salary, not equal to expenses. Okay. So there we have it. Semicolon. So then you can do then 3, 4, 5, 6. Echo salary and expenses are not equal. All right, so we're going to try this one out. And then, of course, you end it with F5. All right, so let's see if this gives us an error. Hopefully not. It should print that they are not the same. So we're going to run it with bash. Salaries are not equal. You see that? If I run this with sh, yeah, you see that unexpected error. So because bash and dash handle things a little bit differently. So just watch out for that. All right, I'll change the script again and just make them the same now. And then it should say that they're. And there you go. All right, so that's pretty simple examples of using bash just to kind of get us started, warmed up. We will, of course, if you remember, Linux is everything's a file, right? So dealing with strings, etc., dealing with files is pretty important. So yeah. All right, let's see. Let's do some loops, I guess. So let's start with a while loop, and then we can try out the for loop. So I'm going to do while loop here. Okay, so nano while underscore loop dot sh. Okay, guys. All right, so syntax is a little different. So again, exclamation, we can do bin bash. I'm going to use, again, this is a while loop. So remember, this is a comment. So now we're going to create a variable n equals 0, for instance. And then you can say while. And in this case, we're going to not have a condition. So it's just going to be a true condition, basically like this, to iterate as if it just basically saying while true. If you say while true, it's like an infinite loop. Okay. So while, and then you can say do, and then just add some spaces, echo, and say countdown, countdown. I mean, it's count up really. And now remember the $n. So basically it's going to print this n, but we're going to need to increment this n, right? Like, like you do in counters. So we can do that here. Just notice we do something like that, and then n plus plus. All right, and now I'm going to hit done. Okay, so let's try this one. And there you go. It's basically incrementing 14, 15, etc. And it's a while loop example. Okay. In some other situations, you want to try out a for loop. So you can hit Control Z to stop it. Right. So Control Z. All right. Now we're going to try similar thing with the for loop. All right. Go ahead and do a for loop. Nano, let's say for loop dot sh. Okay, so again, shebang, bin bash. So now for notice the parentheses again. Okay, then I will use spacing here, one space. And I'm going to say n equal to semicolon n less than or equal to 10. So notice it's got the familiar C++ format for the for loop, and then n plus plus. And then here probably just leave one space. Okay, everyone with me? So yeah, so just do that. And then notice again, it uses these constructs of do and done. Like that. Okay, and then let's add here, let's print it out basically. Echo. So dollar, yeah, n, and then this is like seconds or something. Do you guys see that? So it should print from 2 to 10. Okay, so let's see if it works. There you go. So it printed this 10 times. Any questions? Making sense? All right. So they'll start to get a little gradually harder, as I said, a little bit. But it's important, especially with these, to really pay attention to the syntax, because once you start building your own, it can be challenging. I don't think I'll give you that many to work on, but I'll give you, I'm thinking of the passwd file as a challenge. All right, so we've done the for loop, the while loop, okay? Other things that you might play with are arrays and functions, right? So let's think of, and then after that, we're going to look into like substitutions, cutting, replacing, define and replace, combine, and starting to use some of the commands that we have available. So for instance, last week, what did we do last week? Do you guys remember? We did grep and awk, right? And we did find, right? So imagine now you can, but we only did it on the command prompt, on the command line, but now you can start to integrate that into your bash scripts, for instance, right? So I think I asked you guys to calculate the percentage of the amount of space used by the chem group in the server's hard disk. So that actually took 2 commands, if you remember, right? So I think that's how we did it. So in this, now with a bash script, you can just run both things in the same script, collect the data and variables, put it together. Does that make sense? Yeah. So that's just an example. So we might circle back to that one again, possibly if time permits, but I wanted to point it out just in case you guys were curious of doing that. All right, so but yeah, that's the beauty of it. So you're putting everything together. So we'll try something like that. All right, so we were gonna do, I think, yeah, let's do the functions one. As having functions is a nice thing. Let's call it functions.sh. Right. Okay. Okay, so the same thing, the shebang, bin, bash. And then you basically create a function, so you can call it, hello, and then something like that. Open curly bracket, then close curly bracket, and then in here you can say echo hello world, for instance. Hello world, like that, right? And then to invoke it, we just call the function just by name, so we can just say hello. Does that make sense? So let's try that one. So this is going to be bash, and there you go. So it calls hello world. We might want to define a second function. So let's try that one. You know, we can comment it out. That's similar to Python. Let's do second function, curly bracket, close curly bracket. Let's try echo second function. All right, and we would need to invoke it here. Second function. All right, so let's go ahead and try it out. And you can see it invokes a second function. So you can define multiple functions in there, you know, and work with them. Okay. All right, so I'm going to do clear here. Any questions? All right, so I'm going to keep going. All right, let's do an example of a simple array, very basic array. Okay. So we are going to create, this is similar to Python, like I like a list in Python. It's a similar idea. So if you remember, so let's do, we've done a few. Let's create a new one. Let's call this one simple array .sh. Okay. So now I'm going to do bin bash. You know, let's add a comment again. I'm going to say create an indexed array, for instance. All right. So let's call it index. Oops. Let's call it indexed array. And here we use the parentheses. Okay. And I'm going to say eggs, burger, and milk. Okay. So just a list of items. So this is what I was saying, like in Python, we can have a list of items. So now let's try and see what we can do. So let's iterate over the array to get all the values. Okay, so we're going to try to iterate. So here, notice I'm going to do for I in double quotes $, and then in curly brackets, we're going to add the array itself. Indexed array, square bracket, and then for the index, we are going to plug in an @ symbol. Okay. So this should allow us to extract the values. So now we are going to print them. So do echo $I semicolon, and then finally done. So in one liner, right? So you can do one liners. So let's see if this works. Huh, that's a odd looking script. I'll do bash and it works. Do you guys see that? Just an example how to iterate through an array, changing the for loop, etc. Okay. All right, so there's a few here. Few more. All right, so here's an example of using commands now. So obviously you want to start using the actual Linux commands to solve your problems, right? So this one, it's going to take an input and we are going to cut it by comma and then select the fourth item, third item, etc. Okay, but we're going to create, so let's call this one cut string. I'm going to do nano cut string dot sh, just like that. Hit enter. All right. So let's add the shebang bin bash, right? And so the idea is, I'll add the comments first, I guess. We are going to use the cut command, Linux type command. And then the -d flag for delimiter, which will be comma. So we're going to use the comma for the delimiter. And then we select one of the items because we're cutting. It's like a split basically. So you can think of it as a list now of items. So we are going to, select the nth element with -f, say 3 or so, right? And so these are just Linux commands, right? So, but we're going to write it in a script. And notice most of the code was just comments, actually, and then we can literally just type the command. So cut -d, comma, which is the delimiter, -f, oops, sorry, -f, and then some item, let's say 4. Does that make sense? All right. So what is this going to process? Now we're going to redirect to it some text. Let's just add 3 in here. And we can say something like website, comma, domain, comma, DNS, comma, SMTP, comma, is it 404? 404? Right, 404 or something like that. Okay, so I think with this one, it should give us SMTP, I believe. All right, makes sense. So we're basically just running the actual command. We could have used the read from the previous script to give it through the command line. We might actually do that, but let's just see how it works here. All right, so let's go ahead and run it. So bash, oops. And there you go, gives us back SMTP. Notice that it gave us back the space as well. So probably want to get rid of those space. It's treating that, as a string. All right, so let's try now reading it from the terminal. All right, so we're going to change it a little bit. So we're going to say here, echo, echo. So I'm mixing now script, bash script with commands. So enter your text to split. So then we're going to read text 1. Okay. And so now in theory, actually, I'm going to comment this out. Okay, and instead I'm going to do cut dash D, comma, dash F4, right? And then probably $ text 1. You guys see that? All right, let's see how that goes. And then, so that cut should give us a value, result, and we are going to echo result back. The answer is $ result. Do you guys see that? Does that make sense? All right, so let's try it. Control X, Y. Bash. Enter your text split. So I'm going to look at the other. I forgot. All right, so it's going to be website. Domain. DNS. SMTP 404. All right, so it's not liking syntax error near unexpected token. This one. Let's change this one. Okay, to 3. It's going to do A, comma B, comma C, comma D, comma E. Res command not found. Okay. So then let's try $res. Okay. Oh yeah. Okay. So A, comma B, comma C, comma D, comma E. Command not found. All right, so it's not liking that equal. All right, so let's work this problem and let's try to solve it. So let's do echo instead of that. Here, let me do. Oh, actually, yeah. So let's just run the command like this. I don't know why. It's a Linux thing. All right, so let's do this. Right. I was thinking in Python, right? I have to think in Linux. Right. So in Linux, you don't need to do those things. So it's just you're running that script. Right. You may need to capture the variable, but in our example, actually, we didn't. Does that make sense, guys? Because it just runs the commands and say, all right, this is how we ran it initially. And we didn't need to do anything. Now, it'd be nice to be able to capture something in a variable for further use, right? So let's see. Let me look that up. Unless you guys know. But basically we need a bash to assign command, an assign command output to a variable in a script, basically. So, command substitution. All right, so let's try. I'm going to create a new one here of this one. So I'm going to do Control X. I'm going to copy this cut string to a new version. So I'm going to do CP. And we're going to call this one exactly that, assign. Yeah. What is it? Assign output from command to variable, right? Pretty long, but so I'm going to reuse the same script, but I'm going to just, I want a new one. I'll do clear. Oops. Okay, so it should be that one. It's pretty. All right, so do nano here. Nano, sign. There we go. All right, so now we need to think. So there's two ways, apparently. We can use the backticks or tilde, or we can use parentheses, like the... So I'll try the first method first. So I read the text in here, goes in here. So this command then would be something like myvar, and then equal, and then $, parentheses, like that. And that would include my command, all right, with arguments and so on, right? So let's try this one. So then my var could be echoed out, such as like my var, like that. All right, so let's try this one. I'm going to change this also to 3, just because. All right, so I'm going to do clear. All right, so let's run this one. Bash. All right, so A, comma, B, comma, C, comma, D, comma, E works like magic, right? So that's an example of doing that. Let's try the other technique, which is to use the tilde. And so, yeah, we can just see how that works. All right, so let's go back to the script again. So this gives you more power because now you can do operations. Now you have really the script for calculating the percentage used by a certain user, right, of the hard drive. So now I'm gonna create another variable here. I'll add something like this. And I'm gonna call this one, it's gonna be the same text, but I'm gonna create myvar. Oh, this needs to be a second variable, so 2. That. And it's gonna be these symbols, these, like that. A little backtick thing. All right. And so I'm gonna write the exact same command. So cut -d. I'm gonna use the comma as a delimiter, -f, and I'm gonna change it to 2. Okay. 3. and then it should be text 1 like that. All right. So then we're going to also try to print that one out. So I'm going to say echo the second answer is, and then it should be, oh yeah, $, my var 2. All right. So let's go ahead and try this one out. Clear. All right. So I'm going to change this to something else. Okay. So still 5, I guess that's fine. So BB and also NN. Yeah, it works perfectly. All right. So you see that? So this is a nice little thing to be able to run commands and save the values into variables for further use. All right. So if you remember when we did some backups, we wanted to take the system time, for instance, right, and use it as the file name for the backup. So let's try that. So we're going to assign it, we're just going to keep doing this for a bit. So let's add another example here. In this case, whenever you guys type date on the command line, you get the system date probably. So let's call it now equal $, date. Just like that. And then we may need to process this, or maybe not actually, but let's echo it. So I'm going to do echo $sign now, I think, right? Oops, sorry. $sign. All right, let's see what happens. All right, so this is the date, system date. Let's run it. All right, there's the system date, of course, have available, and so on. Okay. We could also you can repeat if you'd like with the backticks, hopefully to get the same output, and we printed the date. All right. Remember, you can always combine text. So you can say, today is now. Today is Tuesday, April 9th. All right. Perfect. So what's a good command? Uh, I guess, yeah, let's try same thing, but multi-line. I'm gonna add this I'm going to say my var equal, again, $, like that. Oops, sorry, like that, right? So this looks a little bit like jQuery format. Oops. So basically now we can add the line, several lines for the command. So let's try. Do you guys have any commands that you can remember that have two arguments, like two flags? What's a command that had two flags? Like ls-l, something else. Do you remember one? You can just do it with one, but let's try ls, and then you do this one, the backslash, and then -l. Yep. And that should be it. I'll just do that for now. But probably, I guess, like that. And then we can echo this out. Echo. I'm gonna call this my var. So dollars my var 1M. Let's see what happens. And you can see we get the directory listing as before. Any questions? So you could take now, what could you do with this? You could, let's say that I want you to get me that value 286 and put it in that variable. How would you do that? You know how to do it, right? Grep and awk. Remember that? So how do we do that? So we want grep 286, I said, I think, right? So let's do other if would be the parameter. And then awk to get that 286, that's element 5. All right. You guys follow what we're doing? All right, so help me out, right? So you guys, this is from last week's lab, I think. All right, so let's do, I guess, grep and awk var, right? Something like that. $, open parentheses, close parentheses, ls, backslash, yeah, -l, right? And then after this, pipe, right? Because we're going to pipe that in to something. Grep, what was it? Other if? Pipe, awk, right? And then how do we, well, let's just do this for now. And then we still need to figure out the last part. And then I'm going to do echo. The value is, should be 286. Oops, sorry. $, grep, awk, var, double quote. Right. Nope. Let's try it. Clear. Did it work? Didn't work, huh? Didn't work? It did work. All right, it did work. So you can see it here. So we've got the statement that we want. But I want to get the 286, right? So that part we saw with awk, as you remember from the homework assignment. This should say is. Okay, so we need to then gonna do that. Pipe awk. And then who can tell me the syntax for this one? We can look at it, right? We have it in the bright space under grep and awk. Got the PDFs in here. Okay, so we can take a look at the syntax. So awk print, is that all we need? Print. So we are piping. Yeah, I think actually that meal. So awk, single quote, curly brackets, print, $, whatever we need. So I think it was 5, like that. Any questions? Do you guys think that'll work? So these were the counters. Yeah, so print. All right, so let's go with that one. Awk print number 5. So I'm gonna go back to the terminal. Single quote, curly bracket, print, $5, curly bracket, single quote. Right? All right, so let's try it. Nice, right? So this gives you the last piece of the puzzle, as I said, so that you guys can solve the problem of calculating the percentage by running 2 commands, grep and awk, all that stuff, and then just calculating the percentage, doing a math operation basically in your bash script. Any questions? Making sense? Pretty easy, right? Yeah, go ahead, sir.
You show overtime.
How to get the 286?
Yeah.
The code. Yeah. Now, right. So this script is right there. So I'll add a comment here. Using this is a backslash, right? The backslash for multi-line format. Without the backslashes, we can just make it one-liner.
And that's a $sign print there, right?
Yes, this is from the grep and awk example. Yeah. You mean this one here?
Yeah.
Yeah. Right. If you look at the previous module, you can see the PDFs there, and it's like $.
Thank you.
And also right there, print $1. Okay. All right. Yeah, so that's a good example. Let's keep going. See if we can do something else that's interesting. All right, so let's say that I gave you a problem. This is a fun one, I think. Give me for a domain or an IP address, either one, give me the average ping time and write a bash script for it. How do you do that? What do you guys think?
You said the average ping time?
Mm-hmm. Some kind of a ping time. Does ping give you something like that? It does?
It's in the fourth.
Let me see that. Let me see. Did you just ping Google?
I just pinged my local.
Oh,
It's not my spot there. And when you end it, it shows the average, or no, the total time. And then, yeah, no, that's for the average, well.
where?
Do control C when you end it. That's what I did. Is that Z or C?
Z.
I'm doing C. I don't know.
C as in Charlie?
Yeah, I don't know if there's a difference or not, but
I like that. I like that. Okay. All right. So we then that, oh, this is a nice problem actually. Because we've got the min, the average, the max, and the deviation, I assume. So so this might be a nice one to do. All right. So I think we should do this one. So we want to get one of those, right? One of those min average or min or something ping times. So the trick, I think, is to know the flags of the ping command, right? So yeah. All right. So how do we do that? Let's start building the skeleton for this one. I almost want to do this as a separate. Let's do this as a separate script because this one's getting a little bit long. Okay. So let's just create a new one. And this will be a nice one. I will load these two additional ones to the GitHub soon. Let's do nano. Let's call it get average ping time, right? Average ping time .sh, something like that. All right. So let's just build this bash from scratch. It's gonna be bin, oops, sorry, bin bash. All right, I'm gonna add a comment getting the average ping time. Okay. All right, so we are going to now need a command to run. So I'm going to use underscore like this for the command that I'm going to use, which is going to be bin ping. So ping should be in the bin folder. Make sense? All right, great. All right, so we've got that one as a variable currently. So we're gonna call it as a variable. And then we need some kind of a domain, which could be, I guess, ping will work with IP, I think. So let's just do 888 for now. So domain like that, right? And then 8.8.8, right? Okay. So let's actually try this on the terminal first. I think it makes more sense to do that. So it would be ping 8.8.8. And we need to tell it how many. That's dash C, I think, right?
Yeah.
Yeah. Okay. That's 1, 2, 3, 4. And there's the variables. We did 4 of those. Okay, that looks good. What does the dash Q do? Qualified domain name, probably. That's what that means. All right, so if we give it the Q, it wants to do the DNS resolution, I assume, right?
It says that dash Q is a quiet output.
Oh, is it quiet out?
So it probably, yeah, it looks like it still ran it.
It ran it, but no output. Okay, okay. Perfect, perfect. That's even better. So we want to do it quiet output because we don't want to print the results. We just want the final result. Although it wouldn't matter, I suppose. If we had this, we're still gonna ignore it, I think, right? Out of the grep. So yeah. So let's try it actually without the Q and with the Q, just to see. I don't think it'll affect. But we know we can get it, right? So let's do clear here. ls-l. It's called get average ping time, sh. Okay. Yeah, nano actually. Sorry. All right, so we've got this. This will work. Now we need to construct our variable ping average, right? Equal. Good. Then $, like that, right? That's what we've been doing. Okay. Then we need the command. So the first command is what we wrote on that variable. So to invoke a variable, we need to use the $, again. Yeah, like this thing again, but with curly brackets. Otherwise, we can just type it directly, right? That should also work. But let's try this. So then this is going to be underscore ping like that. Okay. Then let's add the backslash so we can continue down here. The flag, it would be just that dash C4, right? Dash C4. Yeah. And then we need to tell it a domain or something, the IP address. So in that case, $, curly brackets, domain. Right? Do you guys see that? What else do we need? The output of this needs to be what? Piped, right? Needs to be piped into what? Grep. And which one do we grab? The RTT one for now, right? And then we can awk it, maybe. You guys see where I'm going with this? So let's try that. Okay, so we need to end the parentheses here. And then echo. Ping average. Yeah, I think that looks correct. So Control Y. Bash. Well, it's pinging. Oh, there we go, right? So it worked. And we don't need the dash Q actually, because we're grepping anyway. So now, but I want the average. So what do you guys think is the average? The minimum was, well, I guess, let's ping it also. So that we can do this without the Q. Well, let's leave the Q. Without, sorry. Yeah. Okay. So it's doing it. So if you guys analyze this, what does it say? It says the minimum, average, max deviation. So we want the average probably, right? So that means we want this one here. You guys see that? So how do we do that? They're separated by space here. So I want to say this might be 1, 2, 3.
Equal sign count. Or like with the equal sign B3 and then the numbers after that. 4,
It might.
1.
It might be. Because it's the columns. I don't know exactly. This could also be 2, like right there. Let's just try it. Let's just awk it. Because we're not done with awk, but at least it gets us closer. So then here now, we would do what? Pipe, awk, right? And then, no, sorry, curly bracket. Print, $, let's say 3. Yeah, like that, right? Let's try this. Oops, sorry.
It was 4.
It was 4.
I did 4. Like it's just each space.
Mm-hmm. Okay, 4. Okay. All right. So the value was 20, right? 20.087. Yeah. So we still need to get that 20.087. Do you guys see what I'm saying? How do we do that? Very good. All right, so then let's go in here, pipe that in. Cut the delimiter -d, right? Probably that, what was a forward slash? It's a forward slash. Right? You guys want to try that? Okay. It's actually 2. Really?
Yeah.
I guess we need to look at the original one also, just to make sure, because it's changing every time. So what I'm gonna do is, I'm gonna add here all ping vals, right? It'll be very similar, but at least we can see, and that way we'll know for sure. So equal $, this one, move that down. Same thing, $, curly ping, backslash -C4 backslash $, domain pipe grep RTT awk and just print 4. Okay. curly red. Right, so that, and then we need to print this, so. That should be correct. And then let's echo $, all in. Yep.
I did just run it through, the numbers will be different since I think they're running two separate things.
Really? Oh, that's right. You're right. You're right. I didn't think about that one. That's a good catch. So then we would have to store just, I guess, well, then let's just add a third one of these, right? I see your point. It's a very good one. Oh, I'm still in it. Yeah. So what we need to do is all ping vowels needs to make its way into a third one. So other res $, dot, echo all pings ping vowels, right? Pipe. And then we just need to cut it, right? I think. Yeah. Think maybe that'll work. All right. So then we need to echo this one. Right. I think that's correct. Ah, didn't do it. Ping dash C domain. Oh, wait, I have an equal sign here. Oops. Yeah, because that error happened here. Wasn't even in this one. Okay. They worked. All right, so the one that we want is the 1499. If I remember correctly, when we were doing our actual ping, which is this one, the RTT that we want is the second one, the averaging one, correct? Everyone with me? So let's go ahead and we just need to make one little tweak, which is to change, I'm using from all ping vowels, change this to 2. Like that. Control X, Y. Go. 29. And that's it. There you go. Any questions? Make sense? All right, great. So I'll stop here for today. I will load these two scripts to the GitHub and you guys can get them from there. All right. So I'll see you guys on Thursday. On Thursday, we'll just keep working on more bash scripting. Just, doing things.